This is question 5 on the Mod1 Foundation paper from November 2008. And we are told an ordinary 6-sided dice is repeatedly thrown 10 times. The number of 6s are counted for each set of 10 throws. The table shows the results. So let's try and work out what's going on here. The dice has been thrown 10 times, and on the first 10 throws there were 2 6s. So altogether we've had 2 6s out of 10 throws. We'll talk about the last column in a minute. It was then thrown a second time 10 times. So this is the second lot of 10 throws. And in this second lot of 10 throws there were 3 6s. We had 2 6s before, we've now got 3 more 6s. So our total number of 6s is 5. That's the 2 and the 3 added together. And we've now thrown it 2 lots of 10 times. That's 20 times. We've thrown it again, the third time, the third lot of 10 throws. In our third lot of 10 throws, we had a 6 4 times. We'd already had 5 6s. Another 4 6s gave us 9 6s. And this was our third lot of 10 throws, so that's out of 30 throws altogether. So down here, by the time you get to the bottom row that's filled in, the 7th lot of 10 throws had 4 10s in it. And by the time you had now done 70 throws, you'd had 22 6s. Now the numbers over here, the relative frequency, that is just the number of 6s you've had altogether divided by the total number of throws there have been. So here, if you do 22 divided by 70, that's what your calculator should give you. And that's working out everywhere on that row. It's the same thing. So here, on our 8th lot of 10 throws, we had 2 6s. We'd had 22 altogether, so our new total was 24. And over here, the relative frequency is the number of 6s we had, which is 24, divided by the total number of throws, which is 80. And 24 divided by 80, when you do it on the calculator, is 0.3. On the 9th set of 10 throws, we had another 3 6s. Add that 3 onto that 24, you get 27. So we now need to do 27 6s out of 90 throws. I'm doing 27 divided by 90. That one is also 0.3. Final one, 4 more 6s. Add the 4 onto the 27, you get 31. 31 out of 100. If on the calculator you do 31 divided by 100, you get 0.31. And there are 3 marks there for that altogether. There's 1 mark for getting those 3 numbers correct, and there's 1 mark for getting any of these here correct, and a final mark for getting all 3 of those correct. So for that one, we've completed the table, which is what we had to do in part A. In part B of the question, we've got to complete the relative frequency graph. Now there are dots on here for 10 throws, 20 throws, 30 throws and 40 throws. Now if we have a look, 40 throws, it's on 0.3. If we look here, 40 throws, which is here 40, 0.3. The next one we've got to do is 50, 0.28. So we come back to here, 50, 0.28. That's 25, 26, 27, 28. Then 60, 0.3, 70, 0.31. 60, 0.3, 70, 0.31. And go back, we need to do 80, 90 and 100. 80 and 90 are both 0.3, that's the same as 0.30. So 2 more at 0.30, there and there. And the final one, the 100 one, is at 0.31. 100, 0.31, that's the final cross. So for part B, where there are 2 marks, we've got to get all of those in the right place. In part C of the question, it says, do these results suggest the dice is biased towards the number 6? Well, you should get a number 6 1/6 of the time. So if we've thrown a dice 100 times, we should get a 6 1/6 of that. And if you do 1/6 of 100, that's dividing 100 by 6, you get about 16 or 17. Now, this isn't on about 16 or 17. This is on about 30. So we've got twice as many as we should have got. So it is suggesting the dice is biased. So if you write down here the reason, okay, 1/6 of 100 is, now if you want to do that as a sum, you do 100 divided by 6. And if you do that on a calculator, you get 16.6. So we would expect that many, but actually we got 31, which is very different. Okay? So if you wrote something down like that, you would get the 2 marks in that question. The key thing is you've got to say that what you got, 31 out of 100, is very different to what probability tells you you should have got. So yeah, there's something dodgy about the dice. It is biased.